This is the continuation of hardware, your second video. Here we're discussing the purpose and role of cache memory and caching. Now, what is caching? Caching refers to the use of a faster medium. So caching is a faster medium to prevent a slower medium from slowing down the performance of a computer. So using a fast medium to prevent a slow medium from slowing down the performance of a computer. For you to understand this concept, there's RAM, there's your CPU, your microprocessor. Cache memory is found between your microprocessor and RAM. This is cache, CPU cache. We're discussing this. Now, to get information or to get data and instructions from RAM is a slower medium and the CPU works fast. So the CPU has to wait for instructions to travel from RAM back to the CPU. Now, the purpose of cache memory is high-speed memory. It's built on your CPU, level 1, and level 2 just outside your CPU. So your cache memory is high-speed memory. It stores data and instructions from RAM that is used often or frequently used. So when the CPU needs instructions, it gathers the instructions from the fast memory rather than going to RAM. So this prevents RAM from slowing down the CPU. This is fast memory. So for the instructions or data being here, it will prevent RAM from slowing down. So it says the use of a faster medium to prevent, this is a faster medium, to prevent a slower medium, this is a slower medium, from slowing down the CPU, the performance. Caching is a technique to store data that is likely to be used soon in a faster form of memory. As I said, whatever we're going to use soon is stored in cache memory. Now, there's more than one type of cache memory. One is your CPU cache. So the diagram here shows you your CPU cache. The CPU cache is faster than RAM. This is a review of what I've discussed. It's faster than RAM. This means that the CPU would waste time waiting for data and instructions to come from RAM. To prevent this problem of the CPU waiting, right? Many CPUs now have a small high-speed cache built into the CPU, where it can temporarily store a small amount of data it needs. So that prevents the CPU from wasting time by getting data from cache memory. Now, disk cache. Remember, your hard drive is slower than your RAM. So when you're loading from your hard drive, it will take longer than to actually work with RAM. So a small amount of RAM that is built onto your hard disk is called your disk cache. Disk cache is a small amount of RAM that's built into your hard drive. So it stores data being sent or received by the hard disk for a short period of time. RAM works faster than storage, reducing the need to wait for files from storage. So here the slow medium is your storage, the faster medium is your RAM. So the files from storage that are needed next is stored in the small disk cache, which is faster because it's called RAM. It's a small amount of RAM. It stores the information or data that is required next. So it makes it faster, makes the computer faster by preventing the need to wait for data from the hard drive. So your disk cache means your hard drive is cached into this built RAM on your hard disk, so it saves time. Now, web cache. Web cache means a small area on the computer's hard drive where images and pages from the World Wide Web are stored. That's your web cache. Now, your hard drive caches, basically, your hard drive is caching your internet. So web cache is an area on your computer's hard drive. This allows you to quickly load images from your computer hard drive rather than the internet the next time you open a page. So you will notice that when you open a web page for the first time, it's coming from the internet, so it takes time to load. If you close the page and open the page again, it opens much faster. That is because it's opening the page from the web cache found on your hard drive. Now, even disk cache, when you're opening an application, like when we open Delphi for the first time, it takes longer to load from your hard drive. But when you open it the second time, if you close the program and you open it again, it loads faster. That's because it's cached. And this is the web cache, where the web pages load faster. Your memory as part of the computer system. Now, I spoke about memory as in your RAM, but there are three types of memory. ROM is read-only memory, RAM is short-term memory, and your storage devices are long-term memory. So the word memory and storage are used often. Remember, your storage devices are permanent. So when you're talking about permanent or long-term memory, that's your storage. Short-term memory is your RAM. There's an example of a picture of a ROM chip. Your ROM is read-only memory and stores the computer's BIOS. It can only read from during normal operation. You can only read from it during normal operation. It prevents accidental deletion of instructions needed by the computer. So therefore it's read only. The ROM is used to required to start off your computer. So you cannot be accidentally or should not be accidentally deleted. Your ROM cannot be changed normally, so the settings are saved on a tiny piece of memory connected to the ROM called a CMOS. Now connected to the ROM is your CMOS. The CMOS needs to have power to keep its data and BIOS settings when the computer is turned off. So it is connected to a small battery. You find a battery on the motherboard. That's for the CMOS to keep its data. This is where you can change your date, time, your boot up settings, from which drive to boot up and so on. You can change these BIOS settings, and this file is stored in your, when these settings are stored in your CMOS, which is next to your ROM. RAM. This is an example of a RAM or DIMM, dual inline memory module. Right, that's your RAM. All active programs and data that is currently being worked on is stored in its RAM. Since the RAM is closely connected to the CPU and has very high read and write speeds, it can ensure the CPU has access to all the data it needs when it needs the data. So your RAM stores the data that the CPU is going to use. I know we spoke about cache, but cache is between RAM and CPU. Is to speed up the process from RAM. And RAM is used to speed up the process from your hard drive. But RAM is your working memory. Cache is very small, high-speed memory to speed up the process. But RAM is larger memory and it's fast memory, it's electronic. Examples of data stored in RAM is information currently shown on your screen. At the moment, this video is on RAM on my computer. Applications running in the background, instructions the computer is busy with, data and instructions the computer might need next is also in RAM. RAM is only used for short-term storage. It is cleared the moment you turn off your computer. Now your storage devices, there's a magnetic tape. That's your magnetic hard drive. Your hard disk, HDD, hard disk drive. Sorry, there's an error here. It's HDD, hard disk drive. Magnetic tape and hard disk drives use magnetic properties to store and retrieve data. This allows large amounts of information and programs to be stored permanently. These devices take longer to read and write information. Now, when we say longer, it takes longer than RAM. It also takes longer than, for example, a solid-state drive. It takes longer to read and write from magnetic drives. Your solid state drive, as with RAM, solid state drives store data on a chip. There's your solid state drive. And it's electronic in nature. It says it uses electricity to store data. Unlike RAM, solid state drives can store data permanently. It uses electricity to store the data, but the data is stored permanently unless you delete it from the solid state drive. Solid state drives are faster but more expensive than your hard disk drive. Your flash drives are like smaller versions of solid state drives. They look like this on the inside, but they are smaller versions. They're electronic, they have a smaller capacity, they're in a portable form of storage. Although you can carry you have external hard drives that you carry around, but this is very portable, it's small, easy for you to move around with. Optical storage media, this is a CD, DVD, similar, and your Blu-ray disc, smaller in size. They use laser technology. So solid state drive is electronic, flash drive is electronic. This is magnetic, your hard drive, and your tape is magnetic. Optical storage uses laser technology to read and write. Your CD, DVD, and Blu-ray discs are cheap, portable storage media that can be used to store data, but they are slower to read from than the previous storage types. So we have a table here showing you the difference between RAM, storage, and ROM. The capacity of RAM is smaller. Your hard drive is larger, your ROM is tiny. RAM is high speed, that's your normal speed, that's very slow speed, your ROM. It's temporary, it's cleared when it loses data, your RAM. This is permanent, but you can change it by deleting files. But it stays, the file stayed there when there's no power, so we call it permanent. Same here. It's permanent because the file stays and there's no power, but you cannot readily change. There are things like EEPROM, erasable, programmable ROM, that can be changed, but requires experts change. Your RAM, there's no user control, it's managed automatically by operating system. Here you control it, you choose what you store. So RAM, automatically whenever you open files, they load it into RAM. Your ROM, there's no user operating system control, it is preloaded software. Preloaded onto your device. Your temporary storage includes RAM. Your memory is your RAM, your cache, your disk cache, they're all temporary storage. Now there's your application. Activity 1.3, page 14. Your computer performance, computer components influence the performance of computer or a smartphone. Now a CPU, it completes the general processing tasks of the computer. Now the performance of your CPU depends on the number of cores, your clock speed, your cache size and speed, and what generation. These are the things when you're buying you need to look at. The number of cores like your i3, i5, and i7. i3 is 2 cores. Your i5 is 4. So it depends on the number of cores. GPU, the cores we'll discuss again when we come to systems to software. Right, your GPU, your graphics processing unit. You also look at the speed, the amount of RAM it has, your memory clock speed and release date. These are the things to look for when you're purchasing it. Your RAM, you look at your generation, whether it's DDR3 or DDR4, the amount of RAM, 4 gigs or 8 gigs or 16 gigs, look at the amount of RAM, the clock speed. That tells you the speed of the components. And your ROM, it stores the BIOS and the motherboard's operating software. That's what your ROM stores. There's no performance factors to consider there. Your HDD, your hard disk drive, you look at the amount of space when you're buying. Depends how much space you want, whether it's in gigabytes or terabytes. Remember, capital letter B is byte. If it's small letter b, it's bit. Speed is normally measured in bits, gigabits or kilobits, and your space is in bytes, gigabytes, terabytes. Revolutions per minute, that means how fast, RPM, revolutions per minute, how fast your hard disk is spinning. Your solid state drive is the amount of space we're looking at it because it's electronic. Your motherboard, you need to look at the correct socket for the CPU, the correct size for the chassis and the ports and the PCI slots. You need to look at all that when you're buying. That means you need to see what components you can connect your motherboard. And your monitor, you look at the resolution, the frame rate, and the color accuracy. High-performance computers typically involve one of the following factors: short response time, high throughput, which refers to rate of processing work, low utilization of computing resources, high availability of the computing system or application, fast data compression and decompression, high bandwidth, and short data transmission time. So if you're looking at this, a low end and a high end computer, this will have 2 to 4. AMD or Intel can have 2 to 4 processing cores, will be a low end. And your Intel with 8 to 16 processing cores will be a high end. Right, and most of your computers have 4 cores. Or 2 cores, and your RAM, most of your computer's RAM is 4 gigabytes RAM. And this is 16 or 32 is high end. Right, this should be capital letter B, gigabyte. This is just speed. This RAM is faster, slower. This is a standard hard drive. For a faster computer, you need a solid state drive. When comparing hardware, websites like AnandTech and Gr11 specialize in testing hardware and be able to tell you exactly how fast one component is than another. A single slow component, such as a standard hard drive in a high-end computer, can impact the performance of a computer system. So you may have fast components and have one single slow component that will impact on the performance of your computer. Storage speed is especially important in 5 situations. Now, why is storage important as well? It's when you're opening a program or a large file and you need to transfer it to RAM. So if the storage is slow, it'll take longer to open. When you're loading your operating system, when installing large applications, when saving large amounts of data, or when transferring data between 2 storage devices, all that impacts, the storage speed will impact on the computer performance. Everything to do with opening programs and loading programs and saving programs. The application will be from the DBE textbook, activity 1.4. Complete your application, boys and girls. Your next video will be on software.